In today's session, I'll discuss with you related to the oscillations. In that oscillations, already you know that different types of motions are having by the particles. Among the different motions of particles, simple harmonic motion plays a major role. Simple harmonic motion. So the conditions of simple harmonic motions already, if a particle is in simple harmonic motion, the conditions which are satisfied by the simple harmonic particle, as you know well, and that is acceleration is directly proportional to displacement, and acceleration and displacement both are in opposite direction. So simply we used to take a concept, that is, if a particle is in simple harmonic motion, that particle has to obey the concept a proportional to minus x and a is equal to minus omega square x. There minus indicates the acceleration and the displacement both are in opposite direction. Getting ma? So when a particle is in simple harmonic motion, it has to travel a periodic motion. A periodic motion. So what is the meaning of periodic motion? The meaning of periodic motion is, for example, this is the mean position. From mean position to extreme position, and again extreme position to came to the mean position, and again from mean position to another end of the extreme position, from another end of the extreme position to travel towards the mean position. All these motions, nothing but all these displacements of particle should be in periodic. What is the meaning of should be in periodic? The meaning is at regular intervals of time, it travels from mean position to extreme position, from mean position to, this is the mean position, from mean position to extreme position to mean position at regular intervals of time. So this is one of the important terminology. When it is in motion from mean position to extreme position, so once again I'm repeating, very important. If a particle is in motion from mean position to extreme position, from where to where, ma? From where to where? Mean position to extreme position. Listen, this is the mean position. From mean position to extreme position, the particle is in motion. At that moment, the condition or the formula for displacement of the particle, the formula for displacement of the particle is y is equal to a sine omega t. This is the formula which you considered when the particle is traveling from mean position to extreme position. Okay, now if the particle is moving initially the particle starts its motion from extreme position. Previously, from where it started, the initial point is mean position. Now what is the initial point? The particle itself is traveling from extreme position. This is the extreme position. This is the extreme position. From here the particle is traveling. See the direction. See the direction. The direction is like this. This is the extreme position. That extreme position here I am representing with plus a. Plus a. And here also one end of the extreme position I am representing it as plus a. So one end of the extreme position is plus a. The other end of the extreme position is minus a. So initially the particle is moving from origin to plus a towards the positive extreme position, extreme end. That is y is equal to a sine omega t. Now the particle initially it is at extreme end. From the extreme end it is traveling towards the mean position. See the direction. I'm saying the word initially. Initially, that's very important term. Now, what about the formula for this? The displacement of the particle can be considered as y is equal to a cos omega t. Y is equal to a cos omega t. Y is equal to a sin omega t from mean to extreme. Here initial position is mean. Y is equal to a cos omega t. That is from extreme to mean. Extreme to mean. This is the mean. Now the particle initially is at extreme. Initially is at extreme. Okay, like that we used to consider y equal to a sin omega t and y is equal to a cos omega t. Are you getting, ma? Are you getting? Now, here I am taking, if the particle is moving from mean position to extreme end, then at any moment, if the particle is present, how much time is taken by the particle to reach that particular point? How much time is taken by the particle to reach that particular point? See, y is equal to 0 to y is equal to a by 2. What is the y is equal to 0? That is the mean position. What is the y is equal to a by 2? For example, this is plus a, one end of the extreme position. In one end of the extreme position, half the distance traveled, nothing but from mean position to this point where I considered the point P, and that is what about the distance, ma? A by 2. So y is equal to 0. This is 0 mean position, and this is exactly half the amplitude. We used to take the word as amplitude. Amplitude is nothing but the maximum displacement done by the particle is known as amplitude. Here a is nothing but amplitude. One end of the extreme position is at a distance. In that I am taking half. So half is nothing but y is equal to, what's the value here? A by 2. So from y is equal to 0 to y is equal to a by 2. From here to here, the time taken by the particle is, what's the time? T by 12. Capital T is the time period here. Capital T is the time period. Next, from where to where it is traveling again? A by 2 to a. Now, this is the mean position. The particle is at a by 2. This is a by 2. Position a by 2. And what is the a? And this end is a. From here to here, if the particle wants to travel from a by 2 to a, if the particle wants to travel, how much time is taken by the particle? What's the time, ma? T by 6. Next, y is equal to 0 to y is equal to a by root 2. A is the amplitude. So 1 by root 2 times of the a. Some distance from the, nothing but in between 0 and a by 2. In between 0 and a by 2. So like this. This is mean position. This is the extreme position plus a. Now somewhere here, this is y is equal to a by root 2. From here to here, if the particle wants to travel, how much time is taken by the particle, ma? What is the time? T by 8. And then again, from a by root 2, nothing but from here to the remaining distance. How much time is taken by the particle? That is again T by 8. These considerations you need to remember in your mind. These are very important at the time of doing numericals. Otherwise, it takes a lot of time to calculate the solution, calculate the problem. So to get the answer, these are the minimum requirements you required for doing the numericals which are involving this topic. Are you getting, ma? అర్థమవుతుందా? Okay. Now, See, and here I'm taking one problem. I'm taking one problem. Two equations are mentioned here. Two equations are mentioned. And those two equations are, okay, once again need to explain this part, no? Right, I can explain that. Listen, ma. Very simple, this topic is. There is no confusion here. There is no confusion. Very simple. You consider this is the mean position and this is one end of the extreme position. Different positions here we are taking. One position is half the amplitude. So half the amplitude means total distance is A, capital A, in that half, nothing but exactly at point P. What is the distance? A by 2. From mean position to half the amplitude, what is the time taken by the particle to reach? That is capital T by 12. Okay, so otherwise you consider you take one tabular column like this. You take one tabular column. Y is equal to 0 to A by 2. T is equal to T by 12. T is equal to T by 12. Next. So A by 2, from A by 2 to A by 2 వరకు వచ్చింది కదా. ఇప్పుడు A by 2 దగ్గర నుంచి ఎక్కడికి వెళ్తుంది పార్టికల్? A దగ్గరికి వచ్చేస్తుంది. మరి A by 2 నుంచి A దగ్గరికి రావడానికి ఎంత టైం పడుతుంది ఇక్కడ? T by 6. So already the particle reached A by 2. From A by 2 to extreme end, the particle has been traveled. How much time taken by the particle to reach from A by 2 to A? What is the time? T by 6. So here you mentioned Y is equal to A by 2 to A. That is equal to T is equal to T by 6. T by 6. Now, some other position in between 0 and A by 2. Some other position. What is that some other position? A by root 2. A by root 2 is the displacement of the particle. From where? From where? From the mean position. From the mean position. So 0 to A by root 2. How much time taken by the particle? What's the time here? T by 8. So now Y is equal to 0 to A by root 2. The time is T by 8. T by 8. And again from A by root 2 to remaining distance. A by root 2 to remaining distance A. So then how much time taken by the particle to reach that? That is Y is equal to A by root 2 to A. The time factor is nothing but the time taken by the particle to reach the extreme end from A by root 2 also. What's the time? T by 8. So these are the four values need to remember. Thereby you can do the numerical easily. Okay, are you getting ma? Good. Now, so I'm taking one problem here. Okay, write down the problem. Two simple harmonic motions are represented by take a problem now. Two simple harmonic motions are represented by y1 is equal to, write down the equation ma, y1 is equal to 10 sine 4 pi t plus pi by 4. 4 pi t plus pi by 4. and y2 equal to phi sine 4 pi t plus root 3 cos 4 pi t. Root 3 cos 4 pi t. So these are the two equations given in the problem. Okay, so what's the question? Calculate the ratio of their amplitudes. Calculate the ratio of their amplitudes that we need to calculate. Okay, now see here. At first, here we are taking these two equations are in the form of y is equal to a sine omega t plus phi. A sine omega t plus phi. So this is in this form, and this also we need to write in the same form. Thereby we can take the amplitudes ratio easily. Both should be in the same form. Then only there is a possible of comparison. Then only there is a possibility of comparison. Okay, now see here. Anyway, y1 is equal to y is equal to a. This is a1. A1. Two equations are there, no? So this is A1, first amplitude. Sine omega t plus phi in that form is present. No problem. Now come to the second one. The second equation y2 that should be taken in the same form. Y is equal to a sine omega t plus phi. For that purpose, y2 is equal to, I'm taking this into some other form. That is, both I'm multiplying with 1 by 2. If I consider 1 by 2, inside also, nothing but here I am taking 2 by 2. 2 get cancelled, again same value. 2 get cancelled, again same value. So that's why here sine 4 pi t, same I am taking the same consideration, root 3 cos 4 pi t. Listen, 5 2s are 10. And here 1 by 2 is there, no? 5 2s are 10. The numerator 2 can be multiplied with the 5. But denominator 2 is there. That is the denominator. So we are writing here 1 by 2. That 1 by 2 I am sending into the brackets. That 1 by 2, whatever here left 1 by 2, 5 2s are 10. This is over. The remaining 1 by 2 is there, no? That 1 by 2 is multiplying with every term in the bracket. A bracket లో ఉన్నటువంటి ప్రతి term తో multiply చేయాలి. So here how come we can say 1 by 2 sine 4 pi t plus 1 by 2 into root 3, that is root 3 by 2. 1 by 2 into root 3 by 2 cos 4 pi t. Now see this 10 into 1 by 2. This I am writing here in the form of cos. How come? Cos 60 equal to 1 by 2. Cos 60 1 by 2. 60 I am writing as pi by 3. Pi means 180. 180 by 3 means 60. So this I am writing here cos pi by 3. This is 60. Cos 60 equal how much? 1 by 2. Sine 4 pi t. This root 3 by 2 is nothing but sine 60. This is sine 60, root 3 by 2. That is I am writing sine pi by 3 cos 4 pi t. Now cos A sin B plus sin A cos B. Cos A sin B plus sin A cos B. That is the formula of sin of A plus B. Sin of A plus B. So that's why here y2 is equal to 10 sin of, what is the A? If you take it as 4 pi t plus what is the B? Pi by 3. Now this is also in the form of a sine omega t plus phi. This is in the form of a sine omega t plus phi, and this also a sine omega t plus phi. Now here in the place of a 10, that is a1 in the first equation. In the second equation, this is A2. A2 equal to 10. So A1 equal to 10 and A2 also equal to 10. I need to take the ratio. Ratio is nothing but how come we consider that? A1 by A2. So A1 by A2 is equal to 10 by 10. Then A1 is to A2 is equal to what's the value, ma? 1 is to 1. That is the ratio. Got this? అర్థమైందమ్మా? అర్థమైందా ఈ మోడల్? సో ఈ మోడల్ అర్థమైందమ్మా క్లియర్ గా? రైట్. Another model here we are taking. Write down that here three different situations are mentioning. Okay, in this in the coming problem, three different situations are mentioning, and those among the three different situations, in between two different situations, we need to take the phase difference. We need to take the phase difference. So how come we consider that? Listen, ma'am. See, what are the three different situations here? The first situation is, and this is the origin, and here A by 2, and this is A by A. Now this is minus A by 2, and this is minus A. First consideration. Now from where the particle is moving, that we need to calculate. Now here I'm taking that first condition is the particle is moving from mean position to A by 2. Mean position to A by 2. So that's why for the indication purpose, here I am taking the dot. Where the dot is present, that point to, from mean position to this particular point, the direction is present. So here in between these two, I need to consider at first phase difference. Now second situation, see here ma, mean position A by 2, same consideration, A minus A by 2 minus A. Now the arrow mark they mentioned as like this. Arrow mark they mentioned as like this. That is second situation. And third situation, same, A by 2, A and this is minus A by 2 minus A. Now where the direction is mentioned as like this, the dot is here. See, what is the meaning of this? At first we will consider the meaning, afterwards what is the aim that we can consider. The meaning is, the first concept meaning is, the particle is moving from mean position to half the extreme position. In this case, y is equal to 0 to A by 2. Y is equal to 0 to A by 2. Next, what is the meaning of second thing? The arrow mark is like this. So what is the meaning of that? The meaning of that is y is equal to, from where the initial position is mean position. So starting position is 0 only. All the three are interlinked. Remember this, all the three are interlinked. 0 to A by 2 is traveling. In the second case, direction is changed. So y is equal to, It reached to 0 to A, and the arrow mark is like this, no? So where is it? Again, A by 2 from, and y is equal to A to A by 2. The meaning of this is 0 to A it traveled. Why? Because continuation of the second, continuation to second one, or continuation from the first one, traveling from mean position to towards extreme. In between A by 2 is present. A by 2 is present. So 0 to A by 2 traveled. In the second case, what it is considering? A by 2 still it is moving towards the positive extreme end and again coming back. So where is the dot? The dot is up to A by 2. So now here we are taking that y is equal to 0 to A and y is equal to A to A by 2. That is the meaning of that. Then what about the third one? It is traveling from continuation from first and second. 0 to A, 0 to A, and again A to 0, and again from 0 to dot. Where is the dot? Minus A by 2. So now here y is equal to 0 to A to 0, mean position, and from mean position to, it is directed towards the negative extreme end, nothing but negative amplitude. So it means where is the dot? Minus A by 2. So it means A to 0 and 0 to minus A by 2. So this is the meaning of all the three diagrams. All the three are interlinked. For a mean position, the particle is traveling, it reached to A by 2, half the amplitude. That is the direction, meaning of this. What is the meaning of this direction? It is coming back opposite to this one. Mean position to extreme position it traveled. From extreme position to, where is the dot? At A by 2, plus A by 2. That is the meaning of that. And what is the meaning of third diagram? Come to the first. From mean position to extreme end, plus A. From A to again 0, mean position, and mean position to traveling towards the negative extreme end, and that is nothing but minus A by 2, the dot is present. So up to minus A by 2, the particle traveled. That is the meaning of all the three diagrams at first. Okay, so are you got these diagrams, ma? Now the question is, come to the question. What is the question? The question is, what is the phase difference between 1 and 2? What is the phase difference between 1 and 3? What is the phase difference between 1 and 2? What is the phase difference between 1 and 3? Okay, now it is very clear. If you want to take the phase difference, at first we need to consider the time periods. We need to take the time periods. So here, as you know well, 0 to A by 2, what is the time period? Previously I said to you that is T by 12. I said to you that is T by 12. The time taken by the particle to travel from 0 to A by 2 is, what's the time? T by 12. Okay, with that I am taking the phase. What is the phase? So the relation between the phase difference and the time difference, phase difference and the time difference is phi is equal to 2 pi by capital T into delta T. This is the formula. Phi is equal to 2 pi by capital T into delta T. Now, here we are taking that. What is the delta T here? What is the delta T? That delta T is 2 pi by capital T. Delta T is T by 12. T get cancelled. Now, this is I am taking phi 1. Phi 1 is equal to T cancel, 2 ones are 2 6 are, and that is equal to pi by 6. That is equal to pi by 6. This is the first one. This is the first one. Okay. Now, come to the second. Where to travel? From 0 to A. 0 to A. So from 0 to A is nothing but what is the meaning of that? 0 to A. The time period is here two time intervals. It traveled from 0 to A and again traveled from A to A by 2. A to A by 2. So for that purpose, here I am taking the concept it as from 0 to A is nothing but So here t is equal to in this case t is equal to 0 to a, that is t by 4 time. Need to remember t by 4 time, and again from a to a by 2, a to a by 2, that is t by 6. A to a by 2, from extreme n to half the distance. A to a by 2, what's the time ma? T by 6. The total time is nothing but, if you take the LCM and if you do that, that time is nothing but 5t by 12. T is equal to, what's the value? 5t by 12. Again, if you substitute this time period in this formula, phi is equal to 2 pi by capital T into delta T. In the delta T place, if you substitute this phi t by 12, then you will get the phase difference as phi 2 is equal to phi t by 6. So phi pi by 6. Sorry, phi pi by 6. Phi pi by 6. So this is the phase case. Now come to this. Here three time intervals we have: 0 to a, and again a to 0, and again from 0 to minus a by. Three time intervals we have. So three time intervals is nothing but, how come we consider that? Listen, 0 to a, 0 to a, and that is t by 4, from mean position to one end of the extreme position, and again a to 0, it is coming back. It is coming back from a to 0. It's coming back again. Again same time t by 4, t by 4, and another one 0 to minus a by 2, from mean position to minus a by 2. From mean position to plus a by 2, whatever the time is taken by the particle, the same time is considered from on mean position to minus a by 2 also. So what is from 0 to a by 2? What is the time? T by 12. The same time is considered here, t by 12. T by 12. Now the time is the total time. If you take the LCM, that is 7t by 12. T is equal to, what's the value ma? 7t by 12. If you substitute this value in the place of delta t, then you will get the phase as phi 3 is equal to this. I am taking it as phi 3 is equal to 7 pi by 6. 7 pi by 6. So three different traveling of motions. In the first case, phi 1 pi by 6. In the second case, phi 2 5 pi by 6. In the third case, phi 3 is equal to 7 pi by 6. 7 pi by 6. Now the question is, what is the phase difference between 1 and 2 and 1 and 3? 1 and 3. So phase difference between 1 and 2 can be calculated as, the first question here I am mentioning here. First question I am taking here. Okay, and that is phi 1 and 2, no? So this is, I am taking delta phi 1, that is equal to phi 2 minus phi 1. This is the phase difference between 1 and 2. Phi 2 minus phi 1. It means what? Phi pi by 6 minus pi by 6. Minus pi by 6. And that is nothing but 4 pi by 6. If you take the 4 pi by 6, and that is nothing but 2 pi by 3. This is the phase difference between 1 and 2. 1 and 2. Then what is the phase difference between 1 and 3? Phase difference between 1 and 3. What is that? And that phase difference is, here we are taking that CM. We are taking that delta phi 2 I am taking here. And that is nothing but phi 3 minus phi 1. In between 1 and 2, phi 2 minus phi 1. In between 1 and 3, phi 3 minus phi 1. What is the phi 3? What is the phi 3 value? 7 pi by 6. What is the phi 1? Pi by 6. 7 pi by 6 minus pi by 6. That is 6 pi by 6. So simply we are taking that 7 pi by 6 minus pi by 6 is equal to 6 pi by 6. And what is the phase difference, ma? That is pi. What is the phase difference here? Pi. Like that, we used to solve this type of numerical. Okay. Now the particle is in motion. The particle is having two different velocities at two different positions and two different accelerations also having at that two positions. At one position, if you take the velocity is v1, at the same position the acceleration is a1. At another position of the particle, velocity is v2, acceleration is a2. Now here we need to calculate what is the angular frequency of that particle. What is the angular frequency? Angular frequency of that particle. Generally, angular frequency is representing with omega, and like that, here we are taking the formula as root over a2 square minus a1 square by v2 square minus v1 square, and that's the formula for that. That's the formula for that. So otherwise, you can say a1 square minus a2 square by v2 square minus v1 square. Anyway, okay. So here at two different positions, at one particular position, velocity is v1, acceleration is a1. At another particular position, velocity is v2 and acceleration is a2. Now, the angular frequency of the particle is, or the angular frequency of the particle which is in simple harmonic motion is, that we need to calculate. So that is angular frequency omega. Direct formula this is, you take this formula. Otherwise, solving this problem is one lengthy. So this is straight away one shortcut. You treat as shortcut. Angular frequency is equal to omega is equal to root over a1 square minus a2 square by root of v2 square minus v1 square. And then like this, we have models, and take one model. In this question, so one equation is mentioned in this question, and write down that equation. Given that x is equal to 10 sine, this is the displacement of the particle which is in simple harmonic motion, mentioned as 10 sine pi by 3t plus pi by 6 centimeters. Displacement is in centimeters. That's given in the problem. So what is the question is, the initial displacement of the particle is. So what is the meaning of initial displacement of the particle? The initial displacement of the particle is called epoch. What's that, ma'am? The initial displacement of the particle is called epoch. Okay, so now, and listen, and this is the displacement equation they mentioned. X is equal to, like that, x is equal to, and then further here we are taking the concept it as, and very simple, that is, I'm saying that the initial displacement is called epoch. What is the meaning of initial displacement? Here? At a time t is equal to 0, whatever the displacement is called, that is called epoch. At time t is equal to 0, the displacement is called epoch. At time t equal to 0, that itself is called initial displacement. Initial displacement is equal to x is equal to t place to 0 పెట్టండి, ఇదంతా 0 అయిపోతుంది. 10 sin pi by 6. Sin 30 is equal to, what's the value? 1 by 2. Pi by 6 means 30. Pi is 180. 180 by 6 is 30. Then that is equal to, what's the value? 5 centimeter. This is the initial displacement of the particle.